This is the chapter practice test for chapter 1 on the numbers unit. So if we go through these questions, I'm only going to do the numerical response and the multiple choice for this lesson. Which of the following numbers is not a prime factor of 14,014? So to do this, you could do this one of two ways. You could do your prime factorization tree, which means you would start off by dividing by 2. So I get 2 times 7,007. Divide that by 7, which is another prime number, and I get 1,001, and so on. Okay? The other thing that I could do too is I could look at these 4 numbers here, 7, 11, 13, and 17, and divide 14,014 by each of those numbers and see which one gives me a decimal answer, because that's the one that's not a prime factor. If it's a prime factor, it's going to divide evenly. And when I do that, what I get is I get 17 as an answer. Okay? If I look at question number 2, it says how many in the list of 7, 11, 17, and 21 are prime factors of 3,234? Again, what I could do is I could divide this number by each of these and see which one's divided evenly without a remainder. And when I do that, I get 7 does, and 11 does, but 17 and 21 don't. So I get 2 for an answer. Question number 1, numerical response, says the sum of all the prime factors of 160,797 is. So that one I do actually have to do the factorization of that. So again, to recall, what are prime factors? They're prime numbers that are a factor of a given number. So prime numbers are 2, 3, 5, 7, anything that I can only divide it by itself for 1. So if I start off with 160,797, I can start off by dividing it by 3. So if I divide it by 3, I get 3 times 53,599. So I could look at this number and I could check to see if I could divide it by 3. And my divisibility rule helps me with that because I've got 5, 8, 13. 13 and 18 is 31. I can't divide 31 by 3, so I can't divide that number by 3. Can't divide it by 5 because it doesn't end in a 5, so I check, can I divide it by 7? And I can. I get 7 times 7,657. Check again. I can't divide it by 2 because it's not even. I can't divide it by 3 because these numbers, when I add them, are not a multiple of 3. I can't divide it by 7, so I keep going up the list, and I can divide it by 13. And I get 13 times 589. Now, if I couldn't divide it by 3 here, I'm not going to be able to divide it by 3 here. I'm not going to be able to divide it by 7. I'm not going to be able to divide it. I can check. Can I divide it by 13? Because I had already checked this number to divide by 7, and it didn't work. So I can check. Can I divide this by 13? No. So I go into my next prime number. After 13, 14 is not a prime, 15 is not, 16 is not, so I get to 17. Lo and behold, I divide this, I get 17 times 31. Sorry, not 17, 19. So 19 and 31 become my final prime factorization. So again, just to review, when I got to this 53,599, couldn't divide it by 2, couldn't divide it by 3, couldn't divide it by 5, so now I divide it by 7. If I can't divide this number by 2, 3, and 5, I'm not going to be able to divide this number by 2, 3, or 5. So I start off with 7. Nope. 8, 9, 10 are not prime numbers. Try dividing it by 11. Nope. Then I get to 13, and then the process repeats. So the sum of these prime numbers, 3 plus 7 plus 13 plus 19 plus 31, I get 50, 60, 73. Okay? Question number 3 is the lowest common multiple of 33 and 110 can be written as a product of prime factors in the form A times B times C times D, where A, B, and C and D are prime factors. And this right here, what it means is the value of A is less than B, the value value of B is less than C, C is less than D. So in numerical order, this is the lowest number, this is the largest number. And they want to know what the value of C is. So to find common multiples, what you do is you factor the number. So if I take 33 and I do my prime factorization, I get 3 times 11. If I look at 110, I get 10 times 11 and 5 times 2. So for my common multiple, start off with my 3 and my 11 in 33. Then I look at 110. I've got a 5, I've got a 2, and I don't need to repeat the 11 because it already occurred once. So then I've got in numerical order 2, 3, 5, and 11. So C has to be 5, which is B for my answer. Question number 2, the greatest common factor of 6,699 and 8,265 is what? So to do this question, because the numbers are so large, I probably want to revert back to my prime factorization. So 6,699, it's not even, so I can't divide it by 2, so I start by dividing it by 3. And I've got 3 times 2,233. Try dividing it by 3 again, it doesn't work. It's not divisible by 5. Now I go to 7. From 7 I go to 11. I get, or actually no, this would be divisible by 7, sorry. 2,233 divided by 7 gives me 319. So I check, can I divide 319 by 7? No. So then it's 319. The next number after 7 is 11. And I get 11 times 29. So now if I look at my 8,265, I can't divide it by 2. And I can divide it by 3 though, because 8 and 2 is 10, 16 and 21. So when I divide it by 3, 8265 divided by 3, I get 2,755. This I can't divide by 3 because I've got 9 and 10 is 19. But because it ends in a 5, I can divide it by 5. I get 551. So I've already done 3, I've already done 5. So now I know I can't divide this by 5, so I start with 7. Can I divide it by 7? No. Can I divide it by 11? No. And if I start looking, the greatest common factor, look at the numbers that I have here. I have a 3. I couldn't do 11. So now, look, could I do 29? So 551 divided by 29 gives me 19 and 29. So the largest common factor ends up being 29. So I can use the results from the first one to help me figure out the common factor of the second one. The lowest common multiple of 14 and 105 is equal to the greatest common factor of the numbers P and Q. Which of the following statements must be false? Okay, so the lowest common multiple, if we figure out common multiples, I have 2 times 7 for this one, and 105 is going to be 5 times 21, which is 3 times 7. So my lowest common multiple is 2, 7, 5, and 3. So 2 times 3 times 5 times 7, which gives me 2 times 7 times 3 times 5 is 210. So the lowest common multiple is equal to the greatest common factor of P and Q. So this is a factor of P and Q, which means P could be a multiple of 7 because the lowest common multiple is 7. It could be a factor of 20 or a multiple of 21 because I've got 21 with my 3 times 7. Could be less than 200 or could be greater than 2,000. 210 is the factor. being the factor of this. And what do we notice? The numbers are bigger than my common factor. So if 210 is my common factor, there's no way that number can be less than 200. It has to be bigger than 200. It has to be bigger than 210. Okay. Question number 5. The partial prime factorization of a number x is shown in the tree diagram. Just need to make sure if I'm still on the screen. So x equals a times b, which is then 2 times 3, 2 times c, 2 times d, and so on. If x is a perfect square, then the minimum value of d is what? So if this is a perfect square, what that means is when I look at this number, this number, this number, this number, and these numbers, I have to be able to put them as a perfect square. I have 1, 2, 3, 4, 5, 6. So I'm going to have 2 groups. 2, 2, 2, 3. So in order for these to be a perfect square, my 2 groups have to be equal, which means D has to be 6. If x is a perfect cube, if it's a perfect cube, that means I'm going to have 3 groups. So if I look at my prime factorization, I'm going to be able to break that up into 3 groups. So I have a 2, a 2, and a 2. 2, 2, 2. And then I have a 3, which means that these 2 numbers here have to be 3. So the minimum value of x is I'm going to have 6 times 6 times 6, which is 216, would become my minimum value. Okay, if we take a look at question number 6, the number represented by this symbol, which we could even call x. This is an irrational number, which means the decimal approximation of x would be what? Well, what's the definition of an irrational number? Irrational numbers are non-terminating and non-repeating. That's D. Okay? If we look at question number 7, which of the following are irrational numbers? So if I start looking through these lists, I'm going to actually start from this end because this number here is the simplest of the numbers. This is a repeating decimal. It's got the line over it. So this is a rational number. Then when I work through, I've got this number right here, the square root of 0.04, which when I use my calculator, I get 2/10, which makes it a rational number. It's a terminating decimal. For this one, I've got the cubed root of 8 over 27. I can split this up. The cubed root of 8 is 2. The cubed root of 27 is 3. That makes it a rational number. And then if I look at the last number, which was the first, 1.010010001000001, this is an irrational number because it's showing that it continues with the dot dots. But it's not a repeating pattern. It's a pattern in that I have 1, 0, 2, 0, 3, 0, 4, 0. But it's not a repeating pattern. This is my irrational number. So 2, 3, and 4 are irrational numbers. Question number 8. The rational number 1.54 repeating can be written as an improper fraction in simplest form of c over d. What is the value of c? So to write fractions, repeating numbers as a fraction, it's a little bit difficult. We didn't spend a lot of time on it, and it wouldn't be on your final exam, but we can go through it because it's still a good skill to have. So what I need to do is I need to do something to get rid of this repeating pattern. So I let x be equal to my 1.545454. If I can get rid of this repeating part through subtraction, then I can actually move this into a fraction. So because my repeating part is 2 decimals, I'm going to multiply it by 100. And what I do to this side, I do to that side. When I multiply this number by 100, I get 1.54545454, which now when I subtract, 100 minus x is 99 x's. The 0.54's cancel out, and I get 154 minus 1 is 153. Divide by 99, and I get to this point. I need to check, is this simplified? So to check that, use your divisibility rules. I know I can divide this by 9 because it's 99. I can check, can I divide this by 9? 1 plus 5 plus 3 is 9. Yes, I can. Divide it by 9, I get 11 on the bottom, and on the top I get 17. So the value of C is 17. Question number 9. M and N are fixed irrational numbers satisfying that M is a value between 30 and 40, and N is a value between 3 and 4. The value of the square root of M plus the square root of N is best represented on the number line by what? So if I take the square root of M, given that M is between 30 and 40, think, what's the square root of 30? It's going to be about 5 point something. Square root of 40 is 6 point something. So M is somewhere between 5 and 6. If I do the same thing with N, because we're talking about the square root of N, square root of 3 is 1 point something. Square root of 4 is 2. So the value of M plus N would be 5 plus 1, which is 6. 6 plus 2, which is 8. So it could be between these two. So I eliminate P and S. Now I might need to be a little bit more creative and actually figuring these out. Okay? So what I could do, the square root of 30 is 5.4, so just about 5.5. Square root of 40 is 6.3. Square root of 3 is 1.7. And the square root of 4 is 2. So 5.5 plus 1.7 gives me 7.2. This is not 7.2. So the minimum has to be 7.2. The maximum can be up to 8.3, so I can be anywhere in between. So R has to be my choice. Okay? Question number 10, consider the following numbers. The largest of these numbers is. So in order to do this, because my radicals have different indexes, I have to figure out the decimal approximation. So the square root of 19 is 4.35. Okay? To find the cubed root, we can use our calculator. And if I want to find the cubed root, what I do is I press math, and it's choice number 4. So 4, and cubed root comes up, 67, and I get 4.06. So I'm going to write that in. Okay. To do the 4th root of 98, I have to press the 4 first, then press math, and it's choice number 5. Now, sometimes the calculator would actually go 4x and then root button, or sometimes it might actually put the 4 as the index. And this is 98, and I get 3.14. Okay. Then we have the 5th root of 201. So I start with 5, math, choice number 5, and 201, and I get 2.88. So the largest of those numbers is the 4.35, which is the square root of 19. Question number 11, the length of a soccer field is 12 times the fourth root of 4,000 meters. In the number 12 times the fourth root of 4,000, the index and the radicand are. The index is the little number, it's the 4. And when it says the word respectively, it means in that order. So the index has to be first. So that eliminates B and D. The radicand is the number that appears underneath the radical sign, which means it has to be A. 12 is the coefficient. Okay. If we look at question number 7, when 7 times the cubed root of 6 is written as an entire radical, what's the value of that radicand? In order to write these as an entire radical, the 7 has to go back underneath the radical sign. The index tells me how many times the 7 has to be multiplied by itself to go underneath. It has to be multiplied by itself 3 times. So then it's 7 times 7 times 7 times 6, or 7 to the power of 3 times 6, and I get 2,058 for my answer. Okay, so now if we look at question number 12, 3 statements are given below. 35 is equal to 7 times root 5. Square root of 5 is close to the square root of 4, which is 2. 2 times 7 is not 35. This is false. Square root of 28 equals 2 root 7. If I wrote 2 root 7 as an entire radical, the index is a 2, because if there's no number, we know the index has to be 2. So that means I multiply 2 by itself twice, multiplied by 7, and I get 28. That's true. I could also do decimal approximations. I could use my calculator. Square root of 28 equals 2 times square root of 7 equals. Statement 3, I've got 4 root 3 equals 48. So again, I'm going to take the 4, multiply it by itself twice, and multiply by 3, and I get the square root of 48. Not 48, the square root of it. So this is false. So the statement that is true is only 2. Question number 13. 3 students are asked to write the radical 4,050 in another form. The answers given were the following. The correct answer was given by which student? So I could check each of these. Check their mixed radical to see if I put it back underneath the radical sign, does it equal 4,050? So if I take the 405, which hopefully looking at it, it's 405 times 405 times 10, which is going to be a ridiculously large number. So 405 squared times 10 gives me 1,640,250. Definitely not 4,050. Okay, so can't be C. Student 2, 15 times 15 times 18. 15 times 15 times 18, 4,050. Okay? So that means that it can't be A, because it can't be only student number 3, because we already have student number 2. So now I'm left between B and D. So I check student 3. 45 times 45 times 2. So if I check that, I get 4,050. So it could be, or it is only students 2 and 3. Question number 14, the area of a circle of radius r is given by the formula A equals pi r squared. A circle of radius 6 has an area of 36 pi. Exactly. If a circle has an area of 120 pi, the exact length of its radius is So the area is 120 pi, and the formula is pi r squared. The pi's are going to cancel out, which now means I have 120 equals r squared. Take the square root of 120. And then if I want, I can do like I've done before, and I can check these. Or I could actually try to write this in a mixed radical on my own. So to do that, I look for perfect factors, like 4, 9, 16. So 120, I can divide it by 4. If I can divide it by 4, I always check, can I divide it by 16? No. Okay? So if I divide this by 4, I get 4 times 30. The square root of 4 is 2, and I get 2 root 30. And I double check. I can't divide 30 by 4, by 9, by 16, by 25. So my answer is C. Numerical response number 5. The volume of a cube of edge length x is given by the formula V equals x cubed. The die has a volume of 720 cubic millimeters. A student determined that the exact length of each side could be written in the form of a cubed root b, where a and b are whole numbers. What would be the value of a plus b? So when I'm looking at my 720, what I'm looking at now is perfect cubed factors. That's the list that's in green. So 8, 27, 64. So 720 divided by 8 works. It actually gives me 90. So 8 times 90. I want to check, can I divide 90 by any of those numbers? I can't divide 90 by 8. Can I divide it by 27? No. Can't divide it by 64, and it gets to be too large. So this is the cubed root, right? So the cubed root of 8 is 2. Cubed root 90. So A plus B is 92. And the last question, consider the following 3 equations. 4 times the cubed root of 3 equals 3 root x. 5 root x equals y root 3. 16 root y equals z root 10. Which of the following statements below is correct? So in other words, what's the order of these numbers? So if we look at the first one, 4 cubed root 3. If I put the 4 underneath, I have to multiply it by itself 3 times, and then multiply it by 3. And when I do that, I get an answer of 192. So x equals 192. I can now put x into this equation. 5 root 192 has to equal y root 3. So check what happens when you divide 192 by 3. You get 64. And 64 is a perfect square. That perfect square is 8. So now I have 5 times 8 root 3, which is 40. Root 3 equals y root 3. So that means that y equals 40. So now I know that x is bigger than y. X is bigger than y. X is bigger than y. Those don't work. X is smaller than y. X is smaller than y. Now if I look at this last one, I have 16 root 40 equals z root 10. This radical is smaller, so simplify this one. 16 is 4 times 10. 4 is 2. The square root of 4 is 2. So now I have 32 root 10 equals z root 10. So z equals 32. So it goes x, or sorry, low to high means it goes z, then y, then x. Z, then y, then x. And D is my final answer.